Welcome to EDU World Space.
Alright guys, we're doing problem number 118 of Chemistry, the Central Science. And it's this chapter 9. So use the average bond enthalpies to estimate delta H for the atomization of benzene and compare that value to that obtained by using delta H of F given in Appendix C and Hess's law. So let's start with delta H. These are our enthalpies right here, the bond enthalpies, and these are delta H formation. So we have our benzene structure right here. We have 3 CC single bonds, 3 CC double bonds, and 6 CH bonds. So let's add this up. 3 times 348 plus 3 times 614 plus 6 times 413. So that's going to be 5,364 kilojoules per mole. And then for Hess's law, delta H of reaction is equal to delta H of products minus delta H of reactants. So 6 times 217.94. Excuse me. Plus 6 times 718.4 minus 82.9. That's going to be 5535. One kilojoules per mole. So you can see that at our enthalpy for as our enthalpy for the atomization of our enthalpy for the atomization based on Hess's law, based on delta H formation, is a bit different than what we see for our bond enthalpy here. And this has to do with the fact that we're calculating our bond enthalpies. We're not taking into account the delta change, the degree at which each carbon and hydrogen are impacting our delta H value. We're just looking at the bond enthalpy of the CC and CH bonds in our benzene. And although carbon and hydrogen do only add a small amount relatively small amount to the delta H value, it is significant enough to cause this discrepancy. When we're doing this calculation, it's as if the C and H they're not taken into account at all, which is not fundamentally accurate.